Welcome back, everyone. We're going to be continuing our lesson on arithmetic sequences. Before the break, I had just derived the formula that we use for arithmetic or linear sequences, but now we're going to be going into an example where we can apply this specific formula. Let's have a look at the board to see our example. So we are asked to consider the sequence 10, 4, -2, -8. We've been asked a few questions on this sequence, so let's have a read through them. Firstly, we've been asked what is the common difference. We then asked to state the values of the next two terms in the sequence. C is asking me to determine a formula for the nth term of the sequence. D is asking me to determine the value of the 20th term. And E is asking if 40 is a term in the sequence, and we're going to justify why it is or why it is not. So let's first consider the sequence. I'm going to write it down for us because we need to determine the common difference. I'm going to give everyone a second at home to think about it. We need to know what the common differences between these terms are. So, between 10 and 4, I can see that I subtracted 6. Then, to get from 4 to -2, I subtracted -6 again. Then, to get from -2 to -8, I subtracted 6 again. So, this means that the common difference is in fact -6. Cool, let's move to question B. So we now need to state the values of the next two terms in the sequence. Great, so we've established that the common difference is -6. So in order to actually determine the value of the next two terms, I'm going to have to subtract 2 from the last term given, and then subtract 6 again. Sorry, I said subtract 2, I meant subtract 6. So we're subtracting 6, and then subtracting 6 again. Let's go to the board. So I'm going to subtract 6 over here. -8 minus 6 will give me -14. Then I'm going to subtract 6 again, which is going to give me -20. So the next two terms of the sequence are -14 and -20. Right, the next question is asking me to determine a general form for the sequence. We know that the general formula for an arithmetic sequence is Tn is equal to A plus n minus 1 D. We know that A is the value of the first term and D is the common difference. Let's write it down and actually determine this formula together. So we said that Tn is equal to A plus n minus 1 D. What is A? I'm hoping that everyone will agree with me that A is equal to 10. Why is A 10? We know that A is the first term. Great. Then what is D? We discussed on the previous slide that D is equal to -6. So when determining Tn, I'm going to have 10 plus n minus 1 times -6. So hopefully everyone can see that all I've done is I've substituted in a value for A, which is 10. Then I've substituted in a value for D, which is -6. I'm now going to simplify. So I'm going to have Tn is equal to 10 minus 6n plus 6. Simplifying that one step further, the general term will be equal to 16 minus 6n. So that is the general term for my arithmetic sequence. Now that we have our general term for our arithmetic sequence, we are going to be able to either substitute in n values to determine the actual values of certain parts of the pattern. Alternatively, we can substitute in Tn values. Tn values are actual values that could occur in the pattern, and by substituting in Tn, we can actually find values for n, which refer to the positions. Let's have a look at the next question together. So, we have been asked to determine the value of the 20th term. We are asked for the 20th term. We are not asked which term is equal to 20. 20 is then going to be my n value that I am going to substitute in. So I'm going to have T20 is equal to 16 minus 6 times 20. So guys, I hope that everyone's happy with what I've done. I've used the subscript of n being 20, and I've substituted n is equal to 20 in order to find the value of the 20th term. So simplifying, term 20 will be equal to 16 minus 120. And if I simplify this further, I'm going to see that term 20 is equal to negative 104. For this specific example, I substituted in n is equal to 20 to solve for the value of the 20th term. I can see that the value of the 20th term, as you can see behind me, is negative 104. Let us move on to the next part of the question. We have been asked, is 40 a term in the sequence? We need to justify our answer why it is or why it isn't. When I'm asked, is 40 a term in the actual sequence? What this is asking me is this Tn value? Because I know when I substitute n for Tn, I'm substituting a number in. So I'm actually going to substitute in 40 for Tn is equal to 16 minus 6n. Something that I do want to point out to everyone is I'm asked, is this a term in my actual sequence? So the fact that the question is actually asking me, is it actually going to be a term, should get some of our cogs turning in our heads, because this is actually kind of hinting at us that there is the possibility that it's not a term in our sequence. But why would it not be a term in our sequence? What are the possible conditions? I just want to point out to everyone that we have to remember for n values, it has to be a natural number. Please remember that natural numbers start at 1 and they go up. So it goes 1, 2, 3, 4, going the whole way up. Natural numbers do not include fractions. They do not include negative values or irrational numbers. They are whole numbers. We know this because I want to be able to determine term 2 of a pattern or term 100 of a pattern. I never have a situation where I say I want term negative 112 of a pattern or term negative a half of a pattern. It always has to be a whole number. So that's already telling me my whole goal for this question is to see if n is an actual whole number. If it's not a whole number, that means that 40 is not a term in the sequence. Let's look at the board to see if it works. So I've substituted in 40 for Tn. So it's going to be subtracted by 16 because I'm going to carry the 16 over. So it's going to be 24 is equal to negative 6n. Then if I divide both sides by negative 6, I'm going to get that n is equal to negative 4. So this has posed a problem to us. We can't find the negative 4th part of a pattern. Terms are whole numbers. So if it was term 4 was 40, then it would be acceptable. But because n is equal to -4, that means that 40 is not a part of this pattern. So let's conclude on the board together. So we're going to say, but n cannot be equal to -4, therefore 40 is not a term in the pattern. Cool. So everyone, what I'm going to do now for the last few minutes of the lesson is I'm going to discuss what I've covered. We have covered that arithmetic sequences have a common difference. Please remember that this is the main property of an arithmetic sequence, and this property can help me with finding general terms and answering specific questions with arithmetic sequences. We then discussed that the general form of an arithmetic sequence is Tn is equal to A plus n minus 1d. I'm going to write on the concept map behind me just to give us a few more ideas of what we've covered in this lesson, so also you can write a bit of a summary for yourself. So we discussed that the common difference can be written as Tn minus Tn minus 1, because we know that the actual value of a term minus the value of the term that comes before that is the common difference. If I'm looking down at the general term, we discussed that A is the value of the first term, and we discussed that D refers to my common difference. Cool. The last thing that we discussed is we actually discussed the general term and how it can actually help me write other terms in terms of their differences. So we discussed that if I were to write term 7, this would be equal to A plus n minus 1d. I would substitute in the 7 for the n, which would leave me with A plus 60. But I can actually skip those steps. I can go straight from T7 to A plus 60. If I asked you for term 11, I could actually skip straight to writing A plus 10d, because I've subtracted 1 from the n number. Cool, guys. So please remember that with the general term, we can substitute in Tn values as well as n values. If I substitute in Tn values, I'm often looking for the n. So please remember that Tn is actual values and n is term numbers. Great. Hopefully this has helped you have a bit more of a background understanding on arithmetic sequences, and if you tune in again sometime soon, you'll see more practice. Great, guys. So now that we've discussed different parts of the arithmetic sequence, we're going to go to an ad break, and as soon as we're back, we're going to dive into some more examples. See you soon.